This is the equipment, more interesting, more well used. An APE for microchip, you have two different kinds with 50 smaller or more dBs depending on the plan, the access area you are working. We have these two equipments. And this here was an example of point to multi-point wireless. With a cheaper XST, we can go with 2 kilometers and give near to 1 gigabit. It was much more than the necessary. With a bigger distance, 8 kilometers, 300 megabits. With equipment with better antenna, like Dina Dish, we can go far. 8 kilometers with 800 megabits, or up to 20 kilometers with 300 megabits. Lots of clients of wireless we have using this technology. The other kinds of scenario we have was the residential clients using access network Ethernet. We have a customer. In the house of the customer, we put a CPE, Ethernet CPE, like Haplight. This Haplight does a PPOS client, and it was a wireless API for the client, only for the client. It was connected by Ethernet network cable to a power box. This power box do a PPOS server, firewall, QoS, routing OSPF, Kiwi, and voltage monitor. This is the photo of the power box. And the power box was connected to VIPNet's backbone, who was connected to internet. Let me see. This is the power box. In the power box, first Ethernet 1, we come with power in to energize this equipment. And in Ether 5, with power off, we come out with energy to another power box, located 19 meters to the other. In the first one, we come with energy, and in the Ether 5, we come with power out, PPO out, more 90 meters, another one. PPO in, PPO out. And with this, we go moving, lots of kilometers. These 3 ports here was used for clients. I can have 3 clients at each 90 meters. And in the other, I have more and more. And you go moving and put more and more clients. If you have more than 3 clients in one space, you can put another power box. You use the Ether 4 to energize a second power box. You will have 2 clients in the first power box and 4 clients in the second power box at the same point. This is the line in where the energy comes, the power off to the other power box, and the clients. And this is a photo of how it works. Each one of these was a power box. One power box, cable to this house, another cable, Ethernet cable, power box, Ethernet cable, power box, one house, cross the street, another power box, and moving, and you could go to all of a city, lots of, your imagine was more important. In this case here, we see 2 houses at the same power box. We can have up to 3 without a second power box. And in one point, you put one like this, where you put the energy. The energy your batteries, your no brakes, UPSs, to give energy to all of this network. This is extremely cheaper. If you would like to start a network, nothing was cheaper than this. And we use PowerBox, but you can use a simple switch. It will be cheaper than using PowerBox. You lost management, but you reduce your cost. The third scenario was residential fiber. In residential fiber, we have a customer, ONU in the customer, connected to a OLT, who was connected to a router board who does the PPOE server. Fire, QoS, routing, QE, and go to the backbone. The connection was from one fiber. In connection from fiber, you can use this equipment, another power box, but not a power box with a fiber in. You have a building, three apartments in the building, not necessary lots of NU. We use only one and pass Ethernet cables between the clients in the same place, in the same building, in the same apartment, in different apartments. More clients with only one fiber and only one SFP. And we have another scenario with corporate clients. It was the most important clients who pays more and needs a different kind of service. These clients has a dedicated service. We have only a CPE customer in the customer who does PPOE, Fire, QoS, and others, and one dedicated fiber directly from the customer to my switch in the pulp. Clients use fiber to the home. One fiber, lots of splits to attend the clients. The corporate clients, no. They use only one fiber dedicated, connected directly to the switch in the POP. The switch was connected to the router, who was the concentrator, where the services work, and backbone, connection to backbone. The last scenarios was the clients with corporate radios. Oh, fiber was very interesting, but one client who needs internet 100% of the time need more than one internet link and has two different internet links, all fiber. If one car in front of the building of your client shot the fiber, all fibers will be destroyed at the same time. The more interesting scenario was if you have a link in fiber and a backup link with another equipment, with radio was excellent for the second line. Better than two fibers or one fiber and one Ethernet link, for an example, because these two links use has the same risk to stop in front of your house. Was the point of fail, was the two different fibers to the same point. Oh, one fiber was to the left and one from the right. Okay, but in this point, these two fibers was in the same point. And if this point goes down, your internet fails. We have a lot of space in Brazil, and I imagine in all of the world, to the links in radio, corporate links dedicated. And this is the scenario we would have. The customer has a wireless CPE who was configured as a bridge, point to point, not point to multi-point. And in the tower, in the POP, we have a second who was dedicated only for this client. With two antennas, two directional antennas, you have a good signal, the best signal, because one was directly connected to the other, to only one. And you have a good service. In the wireless, we have the other service, and the POP connected to backbone. This is the corporate radios clients, who pays a lot for this kind of service. The VIPNet has a distribution of VPAs. We use the RFC to distribute. The first, we have